Alrighty, let's go, Joe. We're gonna um continue working or trying to understand the USB spec. Um, yeah, so that's pretty much it. I was working on it a little bit yesterday. Um, I have the structure for the HID descriptor, or more so, I think it's called the device descriptor. Yeah, and I believe this is what gets sent first for the information about what the actual USB device is. But I started writing out what I believe will be um, um, what the values would be. So for the vendor ID, what did they put for this? Oh, can you just make up whatever you want? You get how many bytes? Oh, I lost it. Oh yeah, because I replaced it. What was that? I want to copy everything that's in here, and then, oops. Let's go back up here, because I want these values as well. I want to know how long everything is. So 23. This is 1 byte. This is 2 bytes. Oh wait, this isn't everything. Hold up. Class specification. So that would be this. The class code would be 2 bytes, right? And then the country code, that's something else altogether. The number of descriptors. That might be this. But this is going to be 1 anyway. Descriptor length. We'll figure that out later. Okay. So that's fine. I didn't realize that I didn't do much. Right? So we have the vendor, which the vendor ID can just be whatever. So let's just say, I don't know, something random. And then we have the, wait, am I in the right spot? Oh yeah, because I did that mental pack already. So we have the ID of the product ID. I know these cannot be the same, but I have no clue how this is done, because you start with OX4000, and then you add this PID map, but I don't get this part. So we'll come back to this. BCD device. This release number is like USB 2 or whatever. So what is mine? Actually, let me pause this out. Okay, so it said USB 1.1. So USB 1.1. That would be which part? That would be the device. So what it is being device release number in binary coded decimal. So I think this will be, that would be 1, USB 1. So mine would be OX 0110, I think. Okay, so I manufacturer equals index of string descriptor describing manufacturer. Yeah, I don't think this matters. The number of configurations is just going to be 1. I don't know why I started writing equal signs. Right. Okay. So this is our device descriptor. Configuration descriptor. USB device can have several different configurations. Although the majority of devices are simple and only have one, the configuration descriptor describes how the device is powered, what the maximum power consumption is, the number of interfaces it has. Therefore, it is possible to have 2 configurations, one for when the device is bus powered and another one is main powered. As this is a header to the interface descriptors, it is feasible to have one configuration using a different transfer mode. Once all the configurations have been examined by the host will send a set configuration command to non-zero value that which matches the B configuration's values. And returns. So do I need one if... Yeah, I'd assume we need one. Do they have one here? Yeah, the configuration descriptor. But this is like very different. Per USB spec, high-speed capable devices must report device qualifier and other speed qualification or configuration. Device qualifier is mostly similar to device descriptor, since we don't write. Let's report device qualifier. So we don't need that if, yeah, we don't need that. But why is the, is this Enon? Do we not need all of this? Oh, it tells me what the size of it is here. Hmm. Ah, I see. I did do the type right? Descriptor type. Okay, so let me clarify this. This is OX01 for the device descriptor. And also, oh yeah, I already did this here. But let's change this to be descriptors. And then we could do reports later. Right, so let's update that. So here we're looking at I'm still wondering why this is different. So when it asks for this, use the same configuration for both height. So here, where is that defined? This. Oh wait, configuration. But this is just integer. So it gives config number and interface number. Interface count string index. Interface count string index, total length, attributes, power in milliamps. This is all included from TUSB.h. Where is this? Where is this? Where are these libraries at? Okay, is it in here? There it is. So, actually, I can use this for now all the things I was looking for. So, oops. Config to USB. Hmm. What was it? Oh wait, it was TUD underscore. Okay. Well. Huh. I have no clue what this means. Oh. Yeah, I don't think they had that either though. What are we looking for? CDC? Oh, they do have it. But that returns. That just includes something. To here. Hmm. Okay, I'll come back to that later. I want to see the rest of the stuff. So the descriptor type, we're looking for TUSB description device. Okay, where is that defined? Desk. Actually, let's just search the repo. Wait. Desk. Wait, what? Looking for constants. I was looking for this before, wasn't I? So where is this defined then? Yeah, it's, what? Hmm. Okay. NT-way. What was that? Right. Not the report descriptor. The other one. I could be using this. Ooh. All right. Where was I at? What is this? The device descriptor. Oh wait, it gives me. Example USB descriptor for HID class devices. This sample is intended for use. So do not copy this information verbatim, even if building a device. It is important to understand that. Yep. Sample device is a low speed of 105 with an integrated pointing device. This device can be built to just one interface, however, two are used in the example. This device, as a result, there are two interface endpoint HID and report descriptors for this device. Okay, so the length is 12 because. Oh no, you lost me already. Specify the size of this descriptor. 1 byte. Oh, because you have zeros? So you have 17. 17. You subtract 3, that's 15. That's not 15. Excuse me. It's 14. Note that HID class is defined by interface descriptor. Okay. So size. Okay. Size of the descriptor in bytes. I'll have to figure this one out because this has 8 bytes. Oh, no. You start at 0, so you do have 9 bytes. But why is this one 12 when you have 18? I don't know. We'll figure that out later. So for this one, this is the configuration descriptor. I was looking at a report for this. Where's the configuration descriptor? Yeah, this was the short one that I didn't really get. Because here it gave what? When it asked for the descriptor, you returned the descriptor configuration, which is just an array of 8-bit integers with 2 elements in it. Or maybe this holds more than 2 in and of itself. Config number. Shit, let's put this over here. Config number, interface count, which is num interfaces. Then the string index. I don't get that part. The total length, which would be this. The descriptor for, or was it? The attributes. And then the max power. So I think the string index might be the configuration, because we only have one in this example. So we take the first one. No, never mind. This is the first one. I don't know what this string index is though. I don't know. Then you have the HID descriptor. Is that the... No, that's this. Okay, so it probably is multiple. So you have the interface number. That's that one. Then you have the string index again. I don't know what that is. Then you have the protocol descriptor type. What is that? That might be the country code. Then the size of the descriptor, which would be the descriptor length. The HID is this one now. This is like pretty different. What is a boot keyboard? Okay, this is not what I asked for. Okay. Wait, that's actually a little helpful. This is packet of information that describes the device. Packet of information that describes the device. And then endpoint. Oh my gosh. Descriptor. Is standard USB descriptor describing the type and capabilities. Right. HID descriptor. Information about the USB stored in segments of read-only memory. It's pretty broad. Interface descriptor. This is what defines or describes the device as an HID device. Okay. All right, time to go back. I want to see what the difference between this and what I was looking at earlier was. Because for this is the length. This describes what type we're looking at. Don't remember what that is. This describes what type of device it is. Packet size, random information we don't really care about too much. Number of configuration, this is going to be one for us. The report. What does L in front do? It's a interliteral. Oh, I see. I see. Can you do the same thing in C? Oh, well, we don't need it. And Linux automatically load the correct drivers on Windows, even though INF files need to. These numbers need to match the INF file. Don't care about to me. G devices are supposed to implement a halts feature. Fairly if ever used. If you comment this line out, the halt code will be removed, saving 1 or 2 bytes. This is not strictly USB compliant, but works with all major operating systems. Do I have endpoint in here? Endpoint size is 32, but why? I'll probably explain it later. Descriptors are used. Are the data? Yep. Changed items are editable at the top of this file. Changing things in here should only be done. Chapter 9 of the USB spec. Relevant. Did I read chapter 9? Okay, well, I didn't want you to download that. Device request. All USB devices respond to requests from the host on the device's default control pipe. These requests are made using control transfers, request, and parameters are sent in the setup packet. It's responsible for establishing the values passed. It fields every setup package has 8 bytes. Oh, so this is when we send stuff. So we'd already have our like descriptors or whatever, and then when we see one of these, then we send it. Descriptor types, so we have device, configuration, string, interface endpoints. These we don't need. Remote wake up. Oh wait, this is very useful. So the standard device descriptor. Oops, I moved the wrong thing. Wait. So we have wait, this one isn't mine either. I put it over here. I forgot. This can go over there. .1 is 210H. This is USB specification release number. So we're looking for 110H. Wait. Yeah. Field is set to 0. Each interface within a configuration specifies its own class information. So that's what we did here. We just will specify it in the interface. Subclass, same thing. So max packet size. Device release. Device. What do I put for device? Oh, this is mine. Right, so it'd be 210 was 2.1. Index of string descriptor. Or wait, string descriptor. String. Okay, I see. So this depends on string descriptor. Okay, now I'm starting to understand. Depends on string descriptor, right? Yes. And this also depends on string descriptor. So number configuration is going to be 0 or 1. This qualifier. About a high-speed capable device. With the request error, the host must not make a request. Okay. Okay, I see. So we don't need this. And they don't do this either. Yeah. So configuration. The configuration descriptor describes information about a specific device configuration. The descriptor contains uses parameter to the set configuration request. Causes the device to assume the described configuration. Okay. So this is for Let's name it the same. Configuration descriptor. So we have b length, which is the size of descriptor. Then we have b descriptor type. Can't we just say, like, we don't have to worry about it, just be like size of whatever you name destruct. Oops. Configuration descriptor type. So this would be OXO2, right? I believe. So yes, so OXO2. Total length. And this is the total length of data returned for this configuration. I'll leave that for later. Enum interfaces. This will be 1, I think. Includes the combined length of all descriptors. Oh. Oh wait, no, I'm looking at the wrong thing. Number of interfaces. Yeah. Present for this configuration. I think it's 1. Configuration value. Value to use as an argument to set configuration request to select this configuration. Interesting. I've never seen this done before. Because this will be 0. This will be 1. Or, sorry, 0. No, because this is a string in and of itself. So this will be 0, this will be 1. Oh, that's clever. Anyway. string descriptor describing this configuration. Interesting, I assume this would be 0. So, configuration, characteristics. String index, and the total length. Oh, here we go. Attributes. Config, remote wake up. This configuration that uses power from the bus and a local source reports a non-zero. And Pmax power to indicate the amount the actual power source at runtime may be determined. So powered, reserved. Yeah, I think it would just be remote wake up. So this would be D5. And then B max power would be max power consistent USB device bus in this specific configuration. Device is fully operational. Alright, let me go back to at least first. Okay, I couldn't find a clear answer on what the max power draw is, but we're just gonna say 50 because for some reason it uses 2s, so 50 is actually 100, so we're looking at 100, but we're gonna say double check this please. Other speed configuration, we don't need that. Now the interface. This one too. Say the length is going to be size of whatever name is struct, and then the descriptor type is, this should be 3, right? No, it's 4. Interface number, 0 base value, so it's 0. Okay, and then interface number, be alternate setting. Value used to select this alternate setting for the interface identified in the prior field. Number of endpoints. Should be the same value described as above. I didn't describe it up there either, so we'll have to figure that out later. interface class. This is there for future standardization. Interface class. Keyboard class, class code. USB. So we have HID X03. Then it should give me the subclass, right? Okay, how do I know the subclasses? Specification defines a usable set. These class codes can only be used in interface descriptors. Yes, we are in the interface descriptor. Yeah, how do I know what the subclass is? Keyboard subclass code USB. Oh, that didn't really help. Oh, wait. No. Those are scan codes. Class value indicating that the device or interface. Anyway. The subclass. We're just gonna say return to this. It's the protocol. Oh, wait. Also return to this. And then the interface value. String descriptor. Did we put it? There was another interface, right? Oh my gosh. OXO1. No, that's the number of them. Interface number. I don't know. Should come from the string descriptor. Okay. Now for the endpoints. So yeah, b length, this is just going to be size of, and b descriptor type. Now which one is this? This is 5. Endpoint address. So address of the endpoint, the address is encoded as followed: the endpoint number, direction. Okay, this is also, I'll come back to this. The attributes. Okay, so I'll have to read about what all these are too. So I don't even know what this word means. Then the max packet size. So yeah, so this also depends on what I choose for this, because you have different behaviors. The interval, pulling intervals for data transfers. Not quite sure what's a suitable value for this. Is that it? Oh, no, you still have the string one too. String descriptor. But for this one, we're gonna come back to all of this. Need to think this through. So we have, but we can still do this. The length, size of, whatever you call the struct, and then the descriptor type. So this is this is the third one. So 3. So that's why we skipped the number. Then we say wlang ID. This looks to be a string. This holds all of these strings we referenced before. Oh, it's not null terminated. Okay. String descriptor 0. Specifying languages supported by this device. Wait. Okay. String descriptors are Unicode, not ASCII. Strings in a USB device may support multiple languages. requesting a string descriptor. Requester specifies the language using 16-bit language ID defined by. Oh, I see. No, this is not what this is. Oops. We want to delete here. This will hold the lang ID. So then we have the language descriptor. And then this is the actual string descriptor. Length is computed by subtracting 2 from the value of the first byte in the descriptor. Okay. So this will be size of struct or whatever. And then the descriptor type. So what is the, here are the two. So this one's 3. Oh, they're both 3. Okay. Okay, so let's just support English for the time being. Or it's gonna be the entire time. So English is OX language code CSV. Oh, that's not what I want to do. Does this? Nope. OX09. Okay, so it's 0409. So then we have this, which then has B string. And this is the strings for the other descriptors. Okay. Let's make sure I did everything right. Nice. Why did I write that one in all caps? Nice. Can I like this and then, oh, that's so nice. And then I could just come here, oop, this, and this. Yeah, that's good. And then let's do the same thing here. Awesome. Yeah. Okay, I think that's good for today. We'll have to do these structures for everything, but I think we're cooling for now. Actually, I can commit this because I changed the files, right? Yeah. So let's this. Bam. All right, cool.